Hello, this is Steven Graffia. I'll be discussing the manufacturing processes involved in creating golf club heads. We hope that through this podcast you will learn how a variety of processes are used to create the clubs you will be using in your next golf game. Before dissecting the specific steps involved in golf club manufacturing, let's take a look at the anatomy of a golf club head. The iron is a specialized club used to strike a golf ball with specific characteristics such as the loft angle, which dictates how far and how high the ball will travel. The hosel is the part of the golf club head that connects it to the shaft, and the sweet spot is the optimal location to strike the golf ball. The golfer aims to transfer as much energy from the movements of his body into the ball. The coefficient of restitution is the efficiency of this transfer. The USGA limits a club's core to 83%, giving birth to a highly competitive search for optimal material, design, and the manufacturing of the highest performing golf club. There are two predominant processes involved in making all types of golf clubs. Most golf clubs used by the average golfer are created using investment casting. In contrast, drivers and high-end irons used by elite golfers are created by a forging process. There are variations that exist between competing companies and the exact processes they use. The process begins with a proprietary mold representing the outer shape of a golf club. A unique mold is required for each specific club to capture the different loft angles. Therefore, a typical set of irons will have 8 to 9 different molds. This video shows a wax tree being dipped multiple times into a quicksand slurry. The typical slurry is a quicksand mixture because of its ability to withstand the extreme temperatures and the ability to form perfectly smooth layers that capture intricate details. The layer is then dried in a very controlled environment and repeated multiple times. Each layer is thicker than the last to create a sturdy shell. The wax-quicksand combination is dried up to 5 times before entering the steam oven. All of the wax melts and can either be siphoned out or poured out of the mold. What remains is the hollowed shell of the quicksand containing the exact shape of the club. The quicksand molds are then heated simultaneously with the desired steel to roughly 1500 degrees Celsius. This prevents cracking and shattering of the mold from the shock of the steel's high temperature. Once the quicksand reaches the proper temperature, the steel is poured into the mold and then left to dry. The timing and efficiency of movement is vital to the pouring step to ensure continuity of material through the club head. Once dried, the quicksand is removed and the steel club heads remain. Unfinished club heads must be carefully removed from the tree before being polished and either sandblasted or glass bead blasted, depending on the manufacturer's specifications. The finishing process is the final step to ensuring the quality standards set by the manufacturer and the USGA are met. While some club heads are made through the casting process, most drivers and high-end irons are made through forging. Forging mainly refers to creating an object by heating a metal plate to high temperatures, then pressing it into shape. Club heads start as long rods that are cut into small pieces, which are subjected to the forging process to make the finished product. In the forging process, different presses are used to form the metal. For steel pieces, 800-ton presses are used, while titanium pieces are normally shaped with 5,000-ton presses. The initial rod piece is cut into billets, which are heated and pressed before a forging die is used. The initial head design starts to be seen. In this clip, a worker is seen using a press to bend the molten billet. He is very careful to avoid touching the billet and the press while it's in use. At this point, the head is too heavy, which means that the press must be used to make it more compact and to remove the extra flashing material from the sides of the club head. After the forging process is complete, some finishing processes are done. Coining and boring are used by companies to make small detailed marks in the piece and to make the connection between the hosel and the club. Other processes like CNC milling may be utilized in order to make unique gaps in the head and to reduce overall weight. To finish the piece, the face of the club is milled flat. Score marks are drawn into it, and then the club is polished through sand or glass bead blasting. A chrome finish is obtained after polishing. An ever-growing technology in the manufacturing industry is 3D printing, and to this date, only one major company has utilized it to create a club head. A custom 3D printer used stainless steel powder and a laser to create a custom designed piece. While the part needed to be cleaned and polished, the majority of the manufacturing process was done by the printer. It was tested, and players didn't notice a difference between it and a manually machined club. Over the coming years, 3D printing costs will go down, which should make the process more readily adapted by the golf club industry. The possibilities for 3D printing clubs are endless. Professionals and businesses could create their own clubs that fit their playing style, and companies can replicate clubs to amazing precision. 3D printing can easily revolutionize the golf club head creation process, and once printing times go down and more materials available, the only limit to a club head will be the designer's creativity.